6. It says, to prove that an identity is true for all permissible values, express both sides of the identity in equivalent forms. One or both sides of the identity must be algebraically manipulated into an equivalent form to match the other side. So the first thing that we do is we draw a line down like that. Okay? You work on, if you can get away with it, work on one side of the identity and that's it. Try not to work on both. However, there is identities where it is better to work on both sides because you'll simplify them and you'll end up with the same. There's a major difference between solving a trig equation and proving a trigonometric identity. Solving the equation determines the value that makes a particular case true. Proven identity shows that the expression on each side of the equal sign are equivalent for all values. So what that means is this: when you solve for x, you're solving to find a value that proves the statement to be true. When you're solving to prove an identity, it's to prove that every single value is going to be true when substituted into that equation that starts it. Okay? So basically you're proving the left side equals the right side. Now, here's the key to this. Tips for proving an identity. I will provide you a few more tips as we go. Easier to simplify a complicated expression than to make a simple expression more complicated. What does that mean? Work on the harder side, the more difficult side of the equation. Second, use known identities to make substitutions. If you cannot see something, look at your identity sheet and see how you can change it. Third, if a quadratic is present, consider the Pythagorean identity first. Sine squared plus cos squared equals 1 is probably your best friend anytime you have squares. Okay? To change, that's your best friend. Rewrite the expression using sine and cosine only. You will see as I go through this one. You want to change to sine and cos. That is often the easiest way to do it. When there's squared values or double angle values, not as easy. But when there is just simply singular angle values, such as x in this case, often easier to just change it to sine and cos. Getting a common denominator. That is a key one. And like I said, I'm going to show you some as we go. Also identifying perfect square, difference of squares. Difference of squares is going to be used a lot. Sine squared subtracts cos squared. Sine x minus cos x, sine x plus cos x. Identifying that. Getting common denominators. Factoring. Also a way in which we can solve these. All of which are keys to or tips to help you solve an identity. The only thing that is going to make you really good at it is to do a lot of them. As many as you can. And we don't have a lot of time to do it. So it is what it is. All right. So in this identity here, I have 1 minus cos squared. I'm gonna work with the right side of this equation. It is more difficult to change this to 3 different trig functions than it is to change those 3 different trig functions to a singular trig function. So we're going to start by simplifying this side. And to do that, sine x, cos x, I'm going to change this identity, which is that. Anytime you use an identity, put it in brackets so that you show that you have substituted in an identity. It's key because you are not being evaluated on the solution at the end. You are evaluated solely on the steps to get you there. All right, now I simplify. Cos x over cos x. What am I left with here? Sine squared x. Using an identity, can I make it look like the left-hand side? The Pythagorean identity. And I finish my statement with an equals at the bottom, and I show that the left-hand side and the right-hand side are equal. Not sure why any of you boys are not writing this down, but you do you. Okay? We got this, girls? All right. Again, it's work. All right, now let's get into a more complicated one. Equals cotanx. Okay. All right. Somebody tell me what you notice between the left-hand side and the right-hand side. Which side's more complicated? Left. The other issue you have is what?
It's cotan, not tan.
Nope.
It's a double angle.
Yes. Carter?
It's a double angle.
On the left side, you have a double angle. On the right side, you have a singular angle. So the first thing that you're thinking automatically, I've got to get those double angles to single angles, identities. So the first step that I do here is work with the bottom one, because sine 2x only has one identity attached to it. What does sine 2x equal? 2 sine x cos x. I've now converted sine 2x. I've now converted sine 2x, right, to single angle. All right. Now, thinking about yesterday, cos 2x, I need to change it. I have 3 options, and I probably want to get rid of the 1 on the top. So which double angle identity am I going to use for this one?
2 cos squared x minus 1.
2 cos squared x minus 1. That's right. The reason I want to use that is that's going to get my 1 subtract 1 to be 0. So what am I left with? On top, I have 2 cos squared x. And on the bottom, I have 2 sine x cos x, like that. All right. Simplify now. 2's cancel. 1 cos on top cancels with the 1 on the bottom. What am I left with? Cos x over sine x, which is equal to? Cotan x equals right-hand side. I am less concerned with you, being able to substitute values in and prove in the left-hand side and the right-hand side. Okay? I don't need you to do that. So like putting in 30 degrees for x and then solving, I'm less concerned about that. I want the identity work to be done because that's what's going to be necessary on the exam. Okay, we've got one more to do here, and it is cos the 4th x minus sine the 4th x, and that should equal cos 2x when we're done with it. Okay. All right. Just cuz. Well, we'll start on the left side. What do you recognize about the left side here? To the 4th. That's right. Okay. What else do you see? Going through your tips. Some of your tips. There's no identity dealing with the 4th, is there? All right. So we can't use the Pythagorean one because it's not squared. Can't use a double angle one on the left side because they're not looking like double angles at the moment, right? Well, I mentioned one to you earlier that is extremely important that you recognize. What do you see about cos 4 to the x minus sine 4 to the x? Difference of squares. Have to recognize that when you see it. Anytime you have a binomial and a subtract between them, chances are you're working with difference of squares. You're good if there's more than squared values. Okay, so if this is difference of squares, this becomes cos squared x minus sine squared x, cos squared x plus sine squared x. All right. Now what do you see?
The cos squared x plus sine squared
Okay.
x is the Pythagorean theorem.
Say that again.
The cos squared x and sine squared x is the Pythagorean.
And what does it equal?
1.
1. That's right. This is 1. That's the first thing that you have to recognize. That's great. Laura, you recognize the other thing. What did you recognize?
I don't know, I was thinking that one.
That was the one you were doing?
Yeah.
Okay, somebody else find the other one that's in there on that sheet.
Cos squared x minus sine squared x is close to x.
What are we looking for in the question? We were looking for this here. How do you get there? The question itself will lead you to the answer. Because you needed to get cos 2x. Well, how do you get cos 2x on what's on the left-hand side? Well, I saw that I had cos squared x minus sine squared x. That is cos 2x. Okay. This is only a 2-mark question. 1 mark for the difference of squares and 1 mark for changing that to that. 2-mark question. Not much work to it, but the recognition of 1, it was difference of squares. 2, that you had 2 different identities on that second step. Okay? You are also going to get a lot of factoring. Let's look at page 208, 1b. Cos squared x minus 3 cos x minus 10.
Yeah, over 8 plus 4 cos x.
Okay, we're being asked to simplify this. Now I have a trinomial on top. The squared value. So what am I going to do here?
King of cos is not cancel.
No, can't.
Factor the top.
You can factor the top. Now, all of that work we put in grade 10 and grade 11 on quadratics and factoring, you're now, and I always said this to you, you'll have to do this when it comes to logarithms, when it comes to trigonometric functions. We got to factor that. So on top, cos x, right? What are the factors of negative 10 that add to give you negative 3?
Negative 5 plus 2.
Negative 5 plus 2. Okay. Now again, we did a lot of polynomial work in grade 11 and 12, where the top and the bottom should match up. So somehow, some way, I'm going to want that bottom to match with the top. What can I do to the bottom of that fraction, to the denominator, so that it may look something like what's on top? Factor out a 4. I take the 4 out of there. What am I left with? 2 plus cos x. Can I cancel anything?
Cos X plus 2.
I can cancel those too.
Where'd your 8 go?
I factored it a 4 out of there.
Oh,
Got a greatest common factor of 4. That's it. That's it. Simplified. Can't do anything else with it. Okay? All right. Anything from yesterday?
View Word B on page 202.
Bet. All right. Okay. So, 8 sine squared 2 theta subtract 4. Okay. All right. It wants us to simplify to a single trig function. Okay. 8 sine squared 2 theta subtract 4. So right now I don't see anything that's going to help me. But when I look at the 8 and the 4, I got to think to myself, there's probably something that needs to be factored out of here. So I'm going to factor out that 4 right now. So I get to that point there. Okay. Oh, sorry. I'll do what they did. They factor out a -4. -4 so that they get 1 minus sine squared 2 theta. Okay. So now
gonna be 2 minus. That's good.
no. Oh, 1 minus 2 sine squared. You're half right, and I'm completely wrong. It's this to that. So I have that there. Okay. What identity is that? 1 minus 2 sine squared theta is equal to what?
Cos 2.
Okay. So I'm just going to loosely write it over here. That is the same as the cos of 2a. So whatever that is, right?
Yeah.
So this is -4 cos double that. Okay. If this was just a, it would be cos 2a.
Oh, because it's a 2.
But because there's a 2 theta there,
Yeah.
I times that by the 2 to get to the 4.
Oh, okay.
So there's actually somewhat two identities within that to get you to there. Okay? All right. Any other questions from yesterday? Anybody get to 7 or 8 yet? Or 9, I mean, 8 or 9? No? Okay, I do want to show you 8. All right. You're going to get today and tomorrow to finish up to the end of 6.3. But there is quite a bit of work. This question 8 and question 9 are guaranteed test exam questions. So we want to have a quick look at them as we are doing this. All right. So it says theta is an angle quadrant 3. So the first thing that you need to do, and we've done this already, is draw your triangle in quadrant 3. The gives us the tan of 7 over 24, right? In which both of those values have to be negative. So that's the first thing that you do. Draw that out. The second thing you do is find out what the radius is. So what's the radius here?
1.
No. 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 There's a whole number 1. The radius, the next thing we have to find, I believe, is 25.
Oh,
7 squared plus 24 squared.
yes.
Is that right? Okay. All right. So there's the first two things. The third thing that you have to do is find these ratios. What is the sine of theta?
-7 over -24.
No, sine,
Sorry, -7 over 25.
right? And then -24 over 25. So there's the first two things that you have to find. So there's 3 things that I've already done, and I haven't even begun to look at the question yet. 3 things that I've already had to do. Okay. Now, it says, find sine theta, sine 2 theta, cos 2 theta, tan 2 theta. So let's work with sine 2 theta first. I'll get you started. Now remember, that's cos theta, sine theta, and tan theta. I want sine 2 theta. So I have to convert that to my identity. So what is sine 2 theta? What's the identity?
2 sine theta cos theta.
2 sine theta cos theta. So I start with my identity. Now, I substitute in. Just like that. Now I just use calculator to simplify that. So the sine of 2 theta. That's right. Okay. Okay. We're good? This is something you'll see on the exam, for sure. Now, just a quick explanation here. Let's say you don't have to write this down or anything. I just want you to understand what's happening here. Let's say I have an angle here of theta. And I found my coordinates here, whatever my coordinates were. And you're asked, so that means then that this is cos theta, sine theta, like this. That's what that means. When you're looking for twice the angle, so let's say that this was greater than 45, so it's somewhere up here. I'd be looking for cos 2 theta, sine 2 theta over here. That's that. That's essentially what you're looking for when you're doing the double angles. You're looking for what are the coordinates twice the angle that we've already found there. So it's not as easy to find, so what we have to do is we have to use identities to find them. So this is why we do this. So if I know what these two guys are, and and multiply them and times by 2, I'll get that value right there of sine 2 theta. Okay, so that's what you're kind of working towards there. But this isn't necessary to totally understand this, but you need to be able to do this step process. Draw your triangle, find your radius, find your other two trig ratios, whatever they are, sine or cos. Use your identity, substitute in, solve. 4 marks. Guaranteed to see that. That's an exam question. Okay? All right, you have today and tomorrow, unless there's other questions from yesterday. We have today and tomorrow to do to the end of 6.3. Thursday we do 6.4 and wrap this unit up. Okay? That's right. And we may have to cut down one of the assessment days. Just because I just feel like we're gonna be stressed here right away to get this done.
Can we do an assignment instead of a test?